Imagine you could travel at the speed of light, not the speed of a rocket, not the speed of the fastest spacecraft humans have ever built. The actual speed of light, about 186,000 miles every second. At that speed, you could circle Earth more than 7 times in a single second. So you would think the universe would suddenly feel small. It doesn't. At light speed, the moon is a little more than 1 second away. The sun is more than 8 minutes away. The nearest star after the sun takes more than 4 years. And by the time we reach the largest distance on this list, even light itself needs tens of billions of years to cross it. Today, we're counting down 10 distances in space, each one larger than the last, until the numbers stop feeling like distances at all, and the comparisons get so extreme that by number 1, you may never look at the night sky the same way again. If you enjoy science questions that make reality feel a little stranger, like the video and subscribe. Now let's start with something that already feels impossibly far away. Number 10. Earth to the moon. The moon looks close. On some nights, it seems almost like you could reach out and touch it. But the average distance between Earth and the moon is about 384,000 kilometers, or roughly 239,000 miles. That means you could fit every planet in the solar system between Earth and the moon, side by side, with a little room left over. Now imagine driving there. At 60 miles per hour, non-stop, without stopping for fuel, food, sleep, or traffic, the trip would take around 166 days, almost half a year. A commercial airplane traveling around 550 miles per hour would still take about 18 days if it could somehow fly through space. The Apollo astronauts did it much faster. Apollo 11 reached lunar orbit in roughly 3 days. That sounds impressive, and it is. But on the scale of space, the moon is practically touching us, because the next distance makes the moon look like the house next door. Number 9. Earth to the sun. The sun is about 93 million miles, or around 150 million kilometers from Earth. That distance is so important that astronomers gave it its own unit. 1 astronomical unit, or AU. Light from the sun takes roughly 8 minutes and 20 seconds to reach us. That means when you look at the sun, safely, with proper protection, you are not seeing it as it is right now. You are seeing the sun as it was more than 8 minutes ago. If the sun could somehow disappear instantly, Earth would continue receiving its light for those 8 minutes. Now think about driving to the sun. At 60 miles per hour, the trip would take roughly 177 years. You could leave today, drive every second of every day, and generations of your family would live and die before the car arrived. And yet the sun is only the center of our own small planetary neighborhood. Because once we leave the inner solar system, the numbers start growing much faster. Number 8. Earth to Mars. Mars is strange because there's no single fixed distance between us. Earth and Mars are both moving around the sun. Sometimes they are relatively close. Other times they are on opposite sides of the solar system. At their closest, they can be a little over 34 million miles apart. At much greater separations, the distance can exceed 200 million miles. That changing distance is why we cannot simply launch a spacecraft toward Mars whenever we feel like it. Engineers wait for favorable alignments. Spacecraft then follow carefully calculated paths around the sun. Even with modern technology, a typical journey can take several months, and this creates an interesting communication problem. Radio signals travel at the speed of light. But depending on the positions of Earth and Mars, a message can take from a few minutes to more than 20 minutes to travel one way. So if a rover has a problem on Mars, nobody on Earth can control it like a remote control car. By the time we see the problem, the the rover has already had to make a decision. Mars already feels distant, but Mars is still well inside our solar system. Let's go much farther. Number 7. Earth to Pluto. Pluto's average distance from the Sun is roughly 3.7 billion miles, or about 5.9 billion kilometers. To appreciate how enormous that is, think about sunlight again. Sunlight reaches Earth in about 8 minutes. Reaching Pluto takes roughly 5.5 hours, depending on where Pluto is in its orbit. So when the Sun shines on Pluto, the light arriving there began its journey hours earlier. NASA's New Horizons spacecraft launched in 2006. It was one of the fastest spacecraft ever launched, and it still took more than 9 years to reach Pluto. 9 years. A child could start elementary school when the spacecraft launches and be in high school when it finally reaches its destination. And New Horizons didn't stop. It flew past Pluto because slowing down enough to enter orbit would have required an enormous amount of additional fuel. That tells you something important. Space is not just big. Distance changes what is physically practical. But Pluto is still nowhere near the edge of everything influenced by the Sun. Number 6. The edge of the solar system. Most people imagine the solar system ending around Pluto. It doesn't. Far beyond the planets lies a region filled with icy objects and the distant gravitational influence of the Sun. One proposed outer boundary is the Oort cloud. We have never directly photographed the Oort cloud as a complete structure, but models suggest it may extend tens of thousands of astronomical units from the Sun. Its outer regions could reach roughly 1 to 2 light-years away. Think about that. A light-year is the distance light travels in 1 year. That is about 5.9 trillion miles. So the Sun's distant gravitational neighborhood may stretch a significant fraction of the way toward the next star. At the speed of our fastest spacecraft, crossing this region could take thousands or even tens of thousands of years. Human civilization as we know it is only a few thousand years old. A spacecraft leaving today could still be traveling through the Sun's distant neighborhood after entire civilizations have risen and disappeared. And then, finally, we reach another star. Number 5. The nearest star. The closest star to the Sun is Proxima Centauri. It is about 424 light-years away. That sounds small because the number is only 4. But remember what a light-year actually means. Light travels almost 6 trillion miles in 1 year. Multiply that by more than 4. Now imagine using one of our fastest spacecraft. At current spacecraft speeds, reaching Proxima Centauri would take tens of thousands of years. If humans began the journey during the Ice Age, depending on the speed, they might still not have arrived today. Even if we built a spacecraft traveling at 1% of the speed of light, dramatically faster than anything carrying humans has ever achieved, the trip would still take more than 400 years. At 10% of light speed, it would take around 42 years, not counting acceleration and deceleration. That means interstellar travel is not simply a bigger version of going to Mars. It is an entirely different engineering problem. Energy, radiation, human lifespan, equipment reliability, collisions with tiny particles at enormous speed. Every problem becomes extreme. But Proxima Centauri is still only our nearest neighbor. Now zoom out. Number 4. Across the Milky Way. Our galaxy, the Milky Way, is roughly 100,000 light-years across. Let that number settle for a moment. Light could leave one side of the galaxy today, and humans, 100,000 years from now, would still be waiting for it to arrive at the other side. When that light began traveling, modern civilization did not exist. Agriculture did not exist. Cities did not exist. Recorded history did not exist. Our ancestors were living in a completely different world. And this creates one of the strangest ideas in astronomy. When we look across our own galaxy, we are looking into the past. If a star is 10,000 light-years away, we see the light it emitted 10,000 years ago. It might have changed dramatically since then. It might even be gone. We simply have not received the news yet. The Milky Way contains hundreds of billions of stars. Our solar system occupies one tiny region of one spiral arm. If the galaxy were reduced to the size of the United States, our entire solar system would be microscopic. But the Milky Way is not even the largest object on this list. Not close. Number 3. The Andromeda Galaxy. Look beyond the Milky Way, and eventually you reach Andromeda, the nearest major galaxy to ours. Andromeda is about 2.5 million light-years away. When you see Andromeda in the night sky, the light entering your eyes began traveling before modern humans existed. Think about that. You are looking at ancient photons that have been crossing empty space for more than 2 million years. If an advanced civilization in Andromeda had a telescope powerful enough to see Earth in detail right now, it would not see our cities. It would not see airplanes. It would not see pyramids. It would see Earth as it existed millions of years ago. And the same is true in reverse. What we see in Andromeda today happened about 2.5 million years in the past. In that sense, telescopes are time machines. The farther away we look, the farther back in time we see. But Andromeda is still a nearby galaxy by cosmic standards, because galaxies themselves gather into much larger structures. Number 2. The scale of our cosmic neighborhood. The Milky Way and Andromeda belong to a collection of galaxies called the Local Group. But even that is only a tiny part of a much larger cosmic structure. Our galaxy exists within the region associated with the Laniakea supercluster, an enormous arrangement of galaxies extending roughly hundreds of millions of light-years across. Imagine a map containing tens of thousands of galaxies. Each galaxy potentially contains billions or hundreds of billions of stars. Now zoom out until those entire galaxies look like tiny points. That is the scale we are dealing with. At this level, the Milky Way is no longer a giant spiral structure. It becomes a dot. Our solar system disappears entirely. Earth is too small to represent. And you? There is no meaningful scale on which you could even draw yourself. But despite all of that, we still have not reached the largest distance, because everything we have described so far exists inside the observable universe. And number 1 is where human intuition finally gives up. Number 1. The observable universe. The observable universe is about 93 billion light-years across, and this sounds impossible immediately, because the universe is about 13.8 billion years old. So how can we see something whose current distance is much farther than 13.8 billion light-years? Because space itself has been expanding while the light traveled. The galaxies that emitted the most distant light we can observe were much closer when that light began its journey. During the billions of years that the photons traveled toward us, the universe expanded. So those regions are now much farther away. The observable universe has a radius of roughly 46 billion light-years in present-day distance, a diameter of approximately 93 billion light-years. And that is only the observable universe, not necessarily the entire universe. There could be vastly more beyond what we can see, possibly infinitely more. We do not currently know. There is a cosmic horizon. Light from regions beyond that horizon has not had enough time to reach us. And because the expansion of the universe is accelerating, there are extremely distant regions we may never be able to reach or communicate with, even in principle. Now think about what that means. We began this list with the Moon, a 3-day journey for Apollo. Then the Sun, 8 light minutes. Then Mars. Then Pluto. Then the edge of the solar system. Then the nearest star. Then the Milky Way. Then Andromeda. Then structures containing thousands upon thousands of galaxies. And finally, a universe so large that even traveling at the fastest speed allowed by physics would not make most of it practically reachable. This is why saying humans will eventually travel everywhere is much more complicated than it sounds. Technology can improve. Rockets can become faster. Propulsion can become more efficient. Humans may eventually reach Mars, perhaps even nearby stars someday. But the universe contains distances that are not merely engineering challenges. Some are constrained by fundamental physics. There are places so far away that no spacecraft we can currently imagine would reach them on any meaningful human timescale. And yet, here is the strangest part. Everything you have ever known exists inside one tiny piece of this enormous structure. Every person who has ever lived, every war, every city, every invention, every ocean, every mountain, every memory. All of human history happened on one small planet orbiting one ordinary star inside one galaxy, among an unimaginable number of galaxies. The universe does not make Earth meaningless. It makes the fact that we are here to understand any of this extraordinary. We are tiny enough to disappear completely on a map of the cosmos, yet somehow capable of measuring distances billions of light-years away. And maybe that is the distance our brains have the hardest time processing. Not the distance between galaxies, but the distance between how small we are and how far our minds can reach.